Alright, welcome back to the channel. My name is Lian Duan, and I'm a content creator based here in Maryland. My goal with the channel is to be a resource to DevOps creative thought, tutorials behind the screen content, and honest podcasts. So if you are into that sort of thing, make sure you subscribe to join the Create crew. It goes a long way towards supporting this channel. It makes sure that you never miss out. Today we are focused on Kubernetes Security Best Practices. After you finish the video, you will be deep understand Kubernetes Security Best Practices and how to use them in your project. First best security practice: reduce Docker image size. There are 3 steps for reduce Docker image size. Find the minimum size base image. You can use Alpine to build your base image, or find a slim Docker image as your base image. Reduce OS packages mean only installing neat library in your Docker image. Multi-stage build to only include runtime dependent libraries. Reduce Docker image size means reducing attack surface. Second best practice: run Docker container as non-root user. Create a user and user group to execute command when the container starts up. The user and user group ID need to be over 1000 to avoid reuse OS default user and user group ID. Run non-root user can stop privilege escalation. After your container run with non-root user, debug is a challenge. Analysis app log is one way to find issue inside your app, or run busybox as debug container to check your app related to outside environment. Third best practice: scan Docker image to find vulnerabilities and fix it. Scan Docker image on each software release. In step 1, static code analysis and dependency check. Fortify, Snyk, Prisma are used to static code analysis. And OWASP dependency checker can scan third-party dependency library. The tools run when the code merges in the code repository. If the process takes longer time, we can schedule tasks run them. Fix the code and third-party dependency vulnerabilities in earlier stage. Next step, check Docker file. There are 2 open source projects that can check Docker file: Hide2Lint and Docker Beach Security. In step 3, Aqua Security, Snyk, and Prisma are able to analyze Docker image layer that include Docker base image and app dependencies library. In step 4, Aqua Security, Snyk, Prisma can run cloud environment check such as Kubernetes, AWS, Azure. Also, scan the app in the running environment by OWASP ZAP. The first step will go through each software release or each agile sprint. After each step, you'll get scan result and then triage vulnerabilities because the report may have first positive alerts. Fix the vulnerabilities sooner than later. Fourth best security practice: configure Kubernetes resource quotas. Usually, a Kubernetes cluster shared to multiple teams. If insufficient memory resources are allocated, the application may phase out of memory and crash. There is other scenario. Without the proper planning, the provisioning of a new pod used for testing could lead to other team application outage. In common case, if a pod is stuck in the pending stage, that means the pod cannot be scheduled onto a node. Generally, it is because nodes do not have enough resource, such as CPU or memory. There are 3 quota types: computing resource quota, storage resource quota, object count quota. CPU and memory are under computing resource quota. Computing resource quota can add to naming space level and pod level. The storage resource quota is only for the namespace level. Total Kubernetes objects set up for object count quota in namespace, such as replica site, pods, deploy, etc. Next best security practice is adding Kubernetes security context into container and pod. In Kubernetes, a security context defines privilege for an individual pod or container. The chart for security context from OS level, Linux has 11 security contexts, and Windows only has 1 security context. Kubernetes security context has 3 types: pod security context, container security context, and pod or container security context. The 6th best security practice is using Kubernetes pod security admission. The Kubernetes pod security standard defines a different isolation level for pods. This standard lets you define how do you want to restrict the behavior of pods in clear, consistent fashion. Kubernetes pod security admission released alpha version on the Kubernetes 1.22. All enable admission controller to check user requests one by one in Kubernetes API server. Pod security admission is part of admission controllers. If the request is against by the admission controller, the user request will be stopped. Kubernetes pod security admission is the successor of pod security policy. The pod security policy API is deprecated as of Kubernetes version 1.21 and will removed from the Kubernetes version 1.25. Pod security admission has 6 annotations that can apply in the Kubernetes namespace. And the next best practice is applying Kubernetes network policy. Kubernetes network policy is used to namespace level to isolate the pod network traffic between namespace and inside namespace. As you know, the Kubernetes network model is flat. The default network policy allows pods to communicate with each other. There are 3 tiers microservice app. The front-end microservice pod can toggle to the back-end microservice pod, even the Redis pod. That's not secure. So we can use the Kubernetes network policy, which labels selector for defining which pod can talk to another pod. Kubernetes network policy is able to control ingress and egress. Ingress means inbound network traffic, and egress means outbound network traffic. After network policy is used, front-end microservice pod cannot talk to the back-end microservice pod. Also, a blocked front-end microservice pod talk to the Redis in DB layer. The latest best security practice is principle of least privilege on role-based access control. RBAC is authorization in Kubernetes API server. RBAC was original from Red Hat OpenShift. Role-based access control was on-stream to Kubernetes and is stable as of version 1.8. There are 4 key items in RBAC. We start from the resource. Resource is Kubernetes resource, such as pod, deployment, nodes, etc. The second is role. You see 2 types of roles, role and cluster role. Role is for specified namespace. The cluster role is for all namespace in Kubernetes. Role is used to define rules for actions on resources. Action means verb in Kubernetes world. Verbs can category read-only and read-write. Third, role bounding. Role bounding is the process of a role to entity. In other words, a set of action is permitted for a certain entity on specified resources. Role used to role bounding. Cluster role bounding is used by cluster role. First is entity. The entity is a group, user, or service account. Kubernetes called empty. Kubernetes called entity is subject. Keep the principle of least privilege on role-based access control to make sure your Kubernetes cluster are secure. All topics are completed. If you want to see more detail and hands-on demo for each security practice, please click below video links. Thank you and see you the next time.